To- Today I will talk about metallurgy and the enrichment of ores. You know, several steps are involved, okay, in the extraction of pure metal. Right? Several steps. Metals are not extracted at once, so there are the steps are there to get a pure metal from ores it is now. So first one is enrichment of ores. Enrichment of ores. You know, ores mined from the earth are usually contaminated with large amount of impurities. Okay, such as sand, soil, etc. And so these are called gangs, Gangue, gang. It's okay. Now the metals before, okay, the first step of the metallurgy is to remove this gang, means the impurities which are associated with these ores are removed first. It is Okay, now like then the process used for removing the gang from the ore are based on difference between the physical and the chemical properties of gang and the ore. Okay, so that depends upon how can gang be removed from the ore. So that depends. Okay, that depends the what kind. So what is the physical and the chemical properties of gang and the ore? So right. So gangs cannot be removed at once. So we have to study it first, the physical and the chemical properties of gang and the ore. It's okay. Uh, so next step is extracting metals low in activity series. Is how metals which are less reactive are extracted, less reactive. Okay, in this we will study two metals about mercury and other is the copper. We will study about these two metals. So the oxides of these metals can be reduced to metals by heating alone. Yes, when you heat the oxides of these metals, for example, copper or mercury, mercury oxide or copper, this mercury sulfide and this copper oxide, so they will be removed. Okay, mercury sulfide is first heated with oxide to convert it into mercury oxide, and the sulfur dioxide is removed. Then again this is mercury oxide is again heated, and that okay after that we get mercury and oxygen we get. So secondly, what do we do for removing this oxygen from copper is that this copper sulfide, first of all the sulfide ores are converted into oxides. Sulfide ores are converted into oxide. Like mercury sulfide is heated with oxygen to convert them into mercury oxide, and in the same way copper sulfide is also heated with oxygen to convert them into copper oxide, and then again that copper oxide is mixed with some copper sulfide ore in the powder form. This copper oxide and copper sulfide ores are heated together to get copper, and this sulfur dioxide gas comes out. Okay. One thing here, just I want to share that the ore of mercury is cinnabar. The ore of mercury is cinnabar. Cinnabar. This is the ore of mercury. cinnabar, and mercury oxide HgS. HgS is known as cinnabar. Okay, so these two metals, mercury and copper, so these two metals are less reactive, and that is why their sulfides ores are first converted into oxide and then again heated to get mercury and the copper. Next, extracting metal in the middle of the activity series, in the middle, and in this case, I will extract zinc. It is a zinc is in the middle order. So metals in the middle order of the activity series are iron, zinc, lead, copper, etc. So they are moderately reactive. So these are usually present as sulfides and carbonate in nature. This mercury, so these metals are available in sulfides and carbonates. Their ores are sulfides and carbonates. It is easier to obtain a metal from its oxide as compared to the sulfides and carbonates. It's okay. So metal oxides can be easily reduced to metal with the help of coke it is, so coke is a great this reducing agent. So it okay so coke removes oxygen from the metal, and metal comes as a pure form. Now, so it is easier to obtain a metal from its oxides as compared to the sulfides and carbonates. So therefore, prior to reduction, the metal sulfides and carbonates must be converted into metal oxides. Okay. Before extraction, metal sulfides and metal carbonates must be converted into metal oxides. The sulfide ores are converted into oxides by heating strongly in the presence of excess of air. And this process is known as roasting. Yes, roasting. This is known as roasting. It is roasting means heating sulfide ores in presence of air, in excess of air. So, and this process is known as roasting. The carbonate ores are changed into oxides by heating strongly in limited air. This here, here the air is limited. It's not sufficient. So this process is known as calcination. So what is calcination? So calcination is a process of heating carbonate ores in limited air. In limited air means in a small amount of air. The chemical reactions that takes place during roasting and calcinations of zinc ores can, just I'm showing you here now on the board. Yes, you can see here on the board that zinc sulfide is heated with oxygen. Zinc sulfide is heated with oxygen to get zinc oxide and sulfur dioxide. So here the oxygen means air. Air means oxygen, oxygen means air it is. So in excess of air, zinc sulfide is heated to convert them into oxides, and this process is known as roasting. Now in case of calcination, this zinc carbonate is heated in absence of air. Look here, there is no oxygen here. There is no oxygen here now. So zinc oxide, we get zinc oxide and carbon dioxide. So both sulfide ores and carbonate ores are first of all converted into oxide ores. Do you know why? It is because it is easy to reduce metal oxide into metal by using coke. So I think we have understood the difference between roasting and calcination. Roasting means heating sulfide ores, okay, in excess of air, and like zinc sulfide is heated in excess of air, then it is converted into zinc oxide. And calcination is a heating of this carbonate ores, okay, in limited air. In limited air means in a small amount of air, to convert them into oxide. So uh, that is we get zinc oxide. It's okay. So now the metal oxides are then reduced to the corresponding metal by using suitable reducing agents such as carbon. Yes, carbon is a very good reducing agent. It's okay. For example, suppose just I am showing you the example. See in this board, look at zinc oxide. This is zinc oxide is heated, okay, with carbon. Zinc oxide is heated with carbon, and carbon is a very good reducing agent. So it has reduced zinc oxide into zinc. It will reduce into zinc. The zinc is here, and the carbon monoxide is given out. This is carbon monoxide. Yes. So carbon monoxide is a very poisonous gas. So this is a simple metallurgy. Okay, this year the syllabus has been reduced, and we have to study only the basic things about metallurgy. Okay, just now I'm concluding the video. Watch it. Thank you.